Hey kiddos, now we're moving on to the final special right triangle, which is the 30, 60, 90. Now this of the two special right triangles is the more complicated one, okay? Remember 45, 45, 90 was x square root of 2? Not the case here for the 30, 60, 90. So obviously none of our values are going to be the same. So a 30, 60, 90 right triangle is called a special right triangle because there's a unique ratio between the legs and the hypotenuse. Obviously, the 30, 60, 90 refers to the angles inside of the triangle. So the ratio is across the 30 degrees is the value of x. Across the 60 degrees goes the value of x square root of 3. And across our 90 degrees goes 2x, 2 times x. So, as before, it is always important that you always label your sides first, and you always label them based off of opposite angles, okay? Opposite angles. Then all we have to do is simply solve for x, figure out what x is, and once you know what x is, then you can easily plug those into all three of these values and simplify. So, what do you need to know? The hypotenuse, which we already know is the longest side, is always twice as long as the shortest leg. Okay, hypotenuse is always twice as long as the shortest leg in a 30, 60, 90. So let's jump into an example. All right, so if given the length of the short leg, find the missing sides. So if we're given the short leg, that means we're given the leg that is across the 30 degrees. Okay, so notice what I went ahead and did was I labeled my right triangle with my sides. Across the 30 degrees goes x. Across the 60 degrees goes x square root of 3. And across the 90 degrees goes 2x. Now, the nice part about this problem is I automatically can see, when given the short leg, that x equals a particular value. So we already know that x equals 5. So to figure out the hypotenuse, 2x, I would just simply plug in 5 for x. So I end up with 2 times 5, which equals 10. So my hypotenuse is 10. So segment DF is 10. Now to figure out the other leg, okay, I'm using x square root of 3. Again, though, we already know that x is equal to 5. So simply, I'm just going to substitute 5 into the place of x. So I get 5 square root of 3. Square root of 3 is already simplified radical, so the answer is 5 square root of 3. Next one, I'm actually going to let you do that practice one on your own. I'm going to go on to the practice 2 to help you guys work this one out. So, again, here, now notice our right triangle is drawn in a different form, but always remember it's across the angles how you mark your sides, all right? Across the 30 degrees goes x. Across the 60 degrees goes x square root of 3, and across the 90 degrees goes 2x. So I already have it all labeled. So now let's see what we know. We know that the value of x is equal to 30 square root of 3. So let us first find the hypotenuse, which would be 2 times x. And in this case, we already know what x is, so it's 2 times 30 square root of 3. Now, to simplify this, we will multiply our coefficients. So 2 times 30 gives us 60. Don't forget to keep the square root of 3. So AY, which is our hypotenuse, is 60 square root of 3. Now to find the other leg, which we know is the x square root of 3 portion. Let's go ahead and plug in our value of x, which is the 30 square root of 3, times, don't forget to bring that down, square root of 3. So this time we're going to multiply our radicals. So end up with 30 square root of 9, but we know square root of 9 reduces to 3, so really we'll end up with 30 times 3, which is a total of 90. So AH is 90. Now, just so that you can check yourself, because some of you might be wondering, hey, I thought the hypotenuse is supposed to be the longest side, and right now it kind of looks deceiving because AH is 90. Well, if you put into your calculator 60 square root of 3, the value as a decimal is 103.9. So clearly that justifies that the AY, which is the hypotenuse, is actually the longest side. All right, so here it's very, very, very important that you guys always get in the habit of labeling your triangles first. Across the 30 degrees goes x. Across the 60 degrees, x square root of 3. And across the 90 degrees, 2x. You have to have this memorized. This is not information that I'm going to give you guys. Same thing goes for the 45, 45, 90. So, first thing I'm going to do is I'm going to label my sides. All right, so I have my sides labeled. Across the 30 degrees is x, across the 90 degrees is 2x, and across my 60 degrees is x square root of 3. For these examples, we're given the long leg, and we have to find the other two sides. So notice when in doing that, I went ahead and I established or set up my equation that's going to help guide me here. So I have that x square root of 3 is equal to 9. So all I have to do here is solve for x. And to solve for x, I have to divide both sides by the square root of 3. I know it cancels out on the left side. And uh-oh, SpaghettiOs, can't have square root in the denominator. So therefore, I must multiply that same square root that's in the denominator to the numerator and the denominator to get rid of it. So now when I multiply that across, you end up with 9 square root of 3 over square root of 3 times square root of 3 is simply 3. Remember that shortcut. Now I can reduce 9 divided by 3, and that actually gives me 3. So I get 3 square root of 3 is the value of x. All right. And, if I know that that's the value of x, and we already know that jk, and I'm not kidding, is 3 square root of 3. So jk is 3 square root of 3. Now to figure out jl is just 2 times that. So 2, right? 2 times x. So that's 2 times 3 square root of 3. Multiply the coefficients. 2 times 3 is 6. Keep the square root of 3. So jl is 6 square root of 3. All right, I'm going to let you guys do practice 3 here on your own. Very similar to the previous example, and I'm going to work out practice 4. So again, you can pause it now, work it out, or wait till I finish practice 4 and then pause it and work it out. Your call. So practice 4, yes, see, they can turn these triangles in all kind of which ways. So still though, it's always based off the location of your angle, and across the angle goes your label. 30 degrees, across from it is x. Across the 90 degrees is 2x, and across the 60 degrees is x square root of 3. Now, in setting that up, I know that 8 square root of 3 is equal to x square root of 3. I'm going to rewrite it with the x being on the left side of the equation. All right, so now let's solve for x, which means I need to divide both sides by a square root of 3. And, that's so nice when it works out so perfectly. And remember, this is not always going to be the case. The square roots of 3's cancel out on the left side and the right side, which tells me that x is equal to 8. Perfect 8. So, Wn is 8. And to figure out what Ng is, I do 2 times x, which is basically the same thing as saying 2 times 8, which is 16. All right, now let's say that you're given the length of the hypotenuse. So now if you're given the hypotenuse, you are to find the other two legs. Okay, so notice very first thing, label your sides. Across 30 degrees is x, across 60 degrees is x squared root of 3, and across the 90 degrees is 2x. I know you're probably tired of me saying it and repeating it, but someone will mess it up, and I'm hoping it won't be you. Yes, you. So here we are identifying that 4 is actually equivalent to 2x. So that's going to be pretty simple for us to figure out what the value of x is. So you got 2x equals 4 is our equation. And I'm going to divide both sides by 2 to get x by itself. And we get that x is equal to 2. So therefore, mn is 2. And then when we plug that into NO, which is x square root of 3, all I have to do is replace the x with the number 2, and I get 2 square root of 3. So NO is 2 square root of 3. All right, you already know that practice 5 is an OYO problem. So I'm going to help you out with practice 6 just because, 1, it's kind of drawn a little differently, and 2, the hypotenuse has a square root. So let's see how we're going to handle this. Labeled, cross 30 degrees, x. Cross 60 degrees, x square root of 3. Cross 90 degrees, 2x. So we have our equation, and I'm going to rewrite it with the x being on the left side. X, or I should say 2x equals 40 square root of 3. All right, got to solve for x. Divide both sides by dos. Those cancel out. And we end up with x equals, well, 40 divided by 2 is 20. And I keep the square root of 3. No problem. So that makes my life easy to know what AC or CA is, because that's actually x. So CA is 20 square root of 3. Now, to figure out what AT is, we get x square root of 3, and I have to substitute in the x for 20 square root of 3. So I get 20 square root of 3 times square root of 3. All right? Now, when I break this down, multiply your square roots. So I keep that's a 30, supposed to be a 20, sorry. Keep my 20. Square root of 3 times square root of 3 is the square root of 9. Hopefully we remember, why do I always remember 3? Sorry, bring down the 20. Square root of 9 is 3. So 20 times 3 is 60. And that is how you would work it out if you are given the hypotenuse and having to find your other two legs. All right, so now let's look at problems with equilateral triangles. So remember that all equilateral triangles are also very unique because their sides are all the same and that their angles are all going to equal 60 degrees. All right, all going to be 60 degrees. So in bisecting an equilateral triangle, what you create are two 30, 60, 90 right triangles. Okay, so you can clearly see that here, that this angle here is being bisected, which we know means it cuts it into two congruent pieces. That's why you get 30, 30. So you end up with a 30, 60, 90 triangle. So keeping that in mind, whenever you have equilateral triangles and they're bisected, they create 30, 60, 90 right triangles. So let us work this out. We're to find the height of the equilateral triangle FGH. Now, I know that this is where the 30 degrees is, here's where the 60 degrees is, and there is where my 90 degree is. Make sure that you label your triangle first. Across the 30 degrees goes x. Across the 60 degrees goes x square root of 3. And across the 90 degrees goes 2x. So we clearly here, given that FG is 14, know that 2x is equal to 14. So to solve for x, we divide both sides by 2. Those will cancel out, and we know that x is equal to 7. Now, I don't need to know what this distance is, okay? They weren't asking for that. They're asking for the height. So the height, okay, is the x square root of 3. So if I have x square root of 3, and we know that x is equal to 7, then all I have to do is plug that in, and I'm left with the answer that the height of this equilateral triangle is 7 square root of 3. All right, awesome sauce. Ciao.